Hello students, so in the previous lecture, in the previous video, we had discussed the first application of dimensional analysis, right? So now in this lecture, we will discuss the second application, that is, with the help of dimensional analysis, we can obtain the relation between different physical quantities, right? That means second application is to obtain the relation connecting different physical quantities, So we will take one or two examples to understand how by making the use of dimensional formula we can obtain the relation between different physical quantity, right? That means suppose if you are being given the question that velocity of an object depends on height and acceleration due to gravity. Right? Obtain the relation between these quantities. This is your question. Right? So in the question, it has been given that velocity of an object depends on height and acceleration due to gravity. This is already given in the question. So to derive the relation between velocity, acceleration and height. So by making the use of dimensional formula, we will obtain the relation between velocity, height and acceleration. Fine. See, velocity depends on acceleration due to gravity, height raised to and height. We don't know how it depends. Right, that means any physical quantity, if you have been said that a physical quantity A depends on B, but from this particular case you will not be able to say that A is proportional to B, A is inversely proportional to B, A is proportional to square of the B. We don't know that. They have just said that A depends on B. So A depends on B can be, A can be proportional to B, A can be proportional to B square, A can be inversely proportional to B. We don't know that, right? Similarly, in our question, they have said that velocity depends on height and acceleration due to gravity, right? But how velocity depends, we don't know that. So by making the use of dimensional formula, we will derive these things. That is why I have written as velocity depends on acceleration due to gravity and height, but we don't know. That means it depends directly, inversely. We don't know that. So I have taken as depends as A, B. So A and B are unknown, right? A and B are unknown. If we'll obtain the values of A and B, then we can get the perfect relation between these three physical quantities. So this is what we are going to do here, right? We will find the value of A, we will find the value of B by making the use of dimensional formula, and then we will write the relation connecting this physical quantities. Clear? See, velocity equals to say any constant, because when you are replacing proportionality sign, you have to multiply any constant. Clear? So velocity is equals to k g raised to a h raised to b. Fine. So we will now write the dimensional formula on both the sides. That means velocity. So it will be m0 L1 t minus 1. K is constant, right? We will not have any dimensional formula for constant term. Acceleration means meter per second square. Meter, that means L1 per second square, t raised to minus 2 a. And h, that means height means length. Clear? We have written the dimensional formula for both the physical quantities given on left hand side and right hand side. So this will be m raised to 0 L1 t minus 1 equals to k. M raised to 0 into a, 0. L raised to 1 into a, L raised to a. T raised to minus 2 into a, minus 2a. L raised to 1 into b, L raised to b. Right? So this can be written as k. L raised to a, L raised to b, L raised to a plus b. T raised to minus 2a equals to m0 L1 t minus 1. Clear? Okay, so now we can compare the power from left and right hand side. That means L raised to a plus b and L raised to 1. So we can say that a plus b is 1. Also t raised to minus 2a, t raised to minus 1. So minus 2a is equals to minus 1. A equals to 1 by 2. A is 1 by 2. Substitute here. A plus 1 by 1 by 2 plus b equals to 1. So b equals to 1 by 2. So both a and b comes out to be 1 by 2, 1 by 2. Substitute these values over here. So v is equals to k, g raised to 1 by 2, h raised to 1 by 2. So this is k root gh. This is the relation. Right? Now in the question, if it has been said that the value of k is root 2, place a root 2. So v is root 2 gh. Clear? So this is how we have obtained the relation between velocity, acceleration and height by taking the use of dimensional formula. Right? We'll see another question, how to obtain the relation, right? See. Now, okay, see another one. Now in the question they are saying that time period depends on length and acceleration due to gravity. Time period of a pendulum depends on length and acceleration due to gravity. Obtain the relation between time period, length and acceleration due to gravity. We'll use the same method, same concept. Constant L raised to a, g raised to b. Now we'll write the dimensional formula. So this is time period, so that will be m0 L0 t1. Constant is length L1 raised to a. G represents acceleration. The acceleration will be meter per second square, meter L1 per second square, t minus 2 raised to b. Clear? Okay. So now this will be m0 L0 t1 equals to k 1 L raised to 1 raised to a. So L raised to a, L raised to b, t raised to minus 2b. Clear? Okay. Right? Now left hand side m0 L0 t1 equals to k L raised to a, L raised to b. So it will be L raised to a plus b and t raised to minus 2b. Clear? Okay, so here L is having the power a plus b, L is having the power 0. So a plus b is equals to 0. T is having the power minus 2b, t is having power 1. So minus 2b is equals to 1. So b is minus 1 by 2. Substitute here. A minus 1 by 2 is 0. So a will be 1 by 2. So a is 1 by 2, b is minus 1 by 2. Substitute in this equation, we'll get t is equals to k L raised to 1 by 2, g raised to minus 1 by 2. So this will be equals to k root of L by g. Clear? Now in the question, if you have been said that the constant is 2 pi, this will be already given to you in the question. So then place 2 pi over here. So this is the relation between time period, length and acceleration due to gravity. Clear? So this is how, with the help of dimensional formula, we can obtain the relation between different physical quantities. So now in the next video, we'll discuss the third and the last application, and then we'll switch on to errors. Clear? Thank you.